Centroid. So why do we want to talk about something like this? Well, we have learned a lot of mechanics problems so far, and when we are analyzing machines or frames or truss, we analyze the force one by one at the support and everything. So if you need to know the force for a truss, we all know how complicated it is going to be, though the solving procedures might not be that bad. But if you combine something like 10 or 20 members in the system, it's somewhat, I don't like to solve that, right? So in a lot of cases, for instance, you have an engine. If you have a 4-stroke engine, most likely it's going to look like this. How many components you think we can include in this specific engine? Of course, I have to shift now. I can assure you it's going to be thousands of components in this specific part, including the piston, the cylinder, everything is going to be a lot of components. So if we follow the procedures we learned in chapter 5, chapter 6, chapter 7, those kind of things, I can assure you it's very unlikely you can calculate everything because it's just way too complex. In particular, this one is just part of your car. So if you say you want to calculating the moving velocity or any other things over here, engine is just small piece over here. So it's very unlikely we're going to do the calculation for all the components parts over here. So instead of treat everything individually, we would like to have a method to integrate everything as one component and calculate for the mechanical property for this specific component. So that's the reason we need to find out the center of gravity and centroid. So when I say center of gravity, it means that over here, even though this can be a very weird shape, I can use a point mass over here and replace the whole thing with just mass. Okay? Then you have mass of tires, you have mass of everything, then you combine everything together and do some calculation, then you got the mass of car located at its gravity center. That is something we're going to learn in this chapter. So how are we going to do that? You can think in two different things. Over here, I'm telling you I have a lot of components, and each component has its own gravity center. So, for instance, if I have 3 of them, W1, W2, W2, and individual ones, I have on the horizontal plane, I have its gravity center located x1, y1, x2, y2, and here is x3, y3. Okay, so if I want to find the gravity center of the combination of those 3 things, I can use a single formula, which is the location of my gravity center in along x direction. This is x, this is y, this is z. That is going to be the total weight of those 3 components. And take the summation of the position multiplied by the weight divided by its total weight. This is my center of gravity. Same for y direction. In x direction, you just multiply by the position in x axis. If you do y direction, it's going to be the same. Okay, like this. Of course, if the z direction of those three components are different, you just add another equation. Then you get everything. Any questions so far? This is just a definition. But sometimes you cannot determine, or you cannot say those things are homogeneous, or this is a cube or anything, so you cannot assure the location of individual components. So how are you going to deal with those kinds of things? Let's say I have something weird in the space. X, Y, and Z. I want to determine its location, but I do know some function of this. I know the geometry function of this thing. So what I'm going to do is, instead of using this is discrete kind of representation of finding the centroid or center of gravity, instead of doing that, I would need to cut everything into small pieces. So every small pieces has its own weight. So everybody took calculus before, right? So this is actually something like this, right? So if I try to find the gravity then it's going to be something like this. This is located at this location. So individual one has its own locations. So if you integrate everything together, you actually have a equation like this, which means the gravity center is going to be the integration in terms of weight divided by its total weight. Y is going to be the same. Z is going to be the same. Depending on different properties, you can replace W with area, with length, with other things, which is something we're going to talk about next session. Any question? Okay, then we're going to have an exam tomorrow, and I'll see you guys next session.